All right, I'm going to go through assigning oxidation numbers. The first thing we're going to do is go through 5 or 6 different rules. You want to have those on the back of your periodic table. The first rule is that unbonded elements have an oxidation number of 0. And so anytime you have an element that's not bonded to anything else, its oxidation number is going to be 0. Second one is that ions will have an oxidation number equal to its charge. Anytime you have an element that has a charge listed, that's an ion, means that ionic charge is going to be its oxidation number. The third rule is that in a compound, the most electronegative element will have an oxidation number equal to its ionic charge. When you're looking at a compound, find the element that's most electronegative. And if you recall, electronegativity increases as you go up the periodic table, and it increases as you go to the right. And again, that should be something on your periodic table, that trend. Once you find the most electronegative, then that's going to be the charge of that element within a compound. The fourth rule is that the sum of oxidation numbers in a compound equal 0, and in a polyatomic ion, its charge. So if you sum up all the elements that make up the compound or polyatomic ion in a compound, they have to equal 0, and the polyatomic ion, they have to equal its charge. Fifth rule is that hydrogen will always have an oxidation number of +1, or if it is only bonded a metal, then it's -1. So hydrogen is always going to be +1. If you have a compound where it's a metal and just hydrogen, just those two, then the charge of that hydrogen will become -1. And the sixth rule, group 1 elements except hydrogen will be +1. Group 2 elements will be +2. Silver will be +2. And aluminum will be +3. Okay, so those elements will never change. It doesn't matter what they're bonded to. So let's go through just a few examples. I'll give you an equation. We'll assign the oxidation numbers, and I'll reference these as we go through the equation. So here's our example. Let's start with about we'll just make one up. Aluminum plus, I don't know, iron oxide. We'll get some iron plus aluminum oxide. And I need a 2 here, 2 here. Now we're balanced. All right, so the first thing we're going to do, we're going to go through and assign the oxidation numbers. I'll go back and reference the rules I'm using. The first thing we have here is aluminum. It's all by itself. It's unbonded. So if you look back, that's rule number 1. Unbonded elements have an oxidation number of 0. So we assign that 0. Then here we have a compound. Rule 3 and 4 talk about a compound. 3 in a compound, the most electronegative element, will have an oxidation number equal to its charge. So we look at iron and oxygen, and if we look back at the periodic table, we've got iron right here, oxygen right here. Oxygen is higher up and further to the right, so that's the most electronegative. So we start by assigning its charge. If you recall, everything in this column has an ionic charge of -2. Go back here, -2. Now what I'm going to do is I'm going to sum these up down below. There's 3 oxygens, each one's at a -2, so that puts us overall at a -6. That means in rule 4, the sum of the oxidation numbers in a compound equals 0. So that means if I total up the 2 irons, the 3 oxygens have to get 0. So we're at -6 for our 3 oxygens. That means my irons have to be +6, but there's 2 of them, so we're going to divide by 2. That means each one's a +3. Okay. Here we have iron by itself, so that's a 0. Again, aluminum, oxygen. If you look at your periodic table, oxygen's more electronegative, so it's -2. -6 means we have to have +6 to cancel it out. There's 2 aluminums, so each one's +3. All right, let's take a look at one more example here. We'll use this. Silver ion plus copper yields the copper ion plus silver, and I believe there's 2 and 2. All right, so again, assigning oxidation numbers. This right here has a charge, so that's considered an ion. So if we go back, ions have an oxidation number equal to its charge. So +1 means it's +1. Copper's unbonded, 0. Copper here now has a charge, so it's an ion. Its oxidation number is +2, equal to its charge. And silver here is unbonded, so that's 0. That's all I have. Hopefully this is helpful.